Welcome to synthetic division. To use synthetic division, please notice that our divisor should have an exponent of 1 and the coefficient should be 1 in front of the x. Okay, synthetic division, this is a shorthand or shortcut way of being able to divide polynomial functions. Okay. This algorithm for synthetic division works only for divisors of the form x minus h. Remember that x plus h equals x minus a negative h. And the number, the h number that you use is the opposite of the number in the x minus h. Okay, we're going to take a look at this using synthetic division to divide. Okay, so notice that we're looking at x to the fourth minus 10x squared minus 2x plus 4, and we are dividing it by x plus 3. So notice we're going to set this up in a very different manner, okay? We're going to set up, they call it an array as follows. Note that a 0 is included for each missing term in the dividend. So just as we had to have term placeholders, every time we're missing a term, we're going to put a 0. Notice our negative 3. That negative 3 that we're going to use is coming from the x plus 3. Remember, x plus h means that your number is really a negative, okay? And that's what we're going to use during this. Okay, so here's our x to the fourth minus 10x squared minus 2x plus 4. And again, we're dividing by the x plus 3. How do we set this up? Please notice that these numbers are the coefficients in front of your terms. So x to the fourth has a coefficient of 1. And then we're missing the x to the cube, right? Term. Okay, so notice we have no x to the cube term, so this is a placeholder. Then we have a minus 10 for x squared, a minus 2, and then a plus 4 for the constant. Okay, the minus 3 again is coming from the x plus 3. Remember, you're going to take the opposite number. We're going to take the 1 and just drop the 1 down below the line. Then what we're going to do is we're going to multiply the negative 3 by 1. That's going to give us negative 3, and we place that under the 0, and then we add these together. So remember, we're always adding together these two numbers here, okay? Then what we do is we, again, multiply the negative 3 by the negative 3, and this time we get 9. And again, we're going to add those together for a minus 1. And again, we come back to our negative 3, multiply it by the negative 1, and then put the 3 up there because negative 3 times negative 1 is 3. We're going to, again, add these together, and we're going to get 1. Again, we will multiply the negative 3 by the 1. This is going to give us a negative 3. We'll add them together, and we'll get 1. Okay? And notice that what happens then is we take all those numbers and they become one less exponent. So we have an x cubed from the 1 minus 3x squared minus x plus 1, and then we still have this one here that tells us we have a remainder, and we're going to have 1 over the divisor of 1 over x plus 3. So there is your remainder. Remember, those were the coefficients from your function, okay? And then this is what we're dividing. That's our divisor, what we're going to divide by. And then that is where the quotient comes from. So remember, these come from and make up your coefficients that are in front of each of those, okay? So that's where everything's coming from. All right, so let's take a look at this. X minus 3, if we did this in long division, in fact, we've done this problem in long division, okay, before. notice that we have a minus 5 left over. Okay, so if we plug a 3 in here, which is coming from this, because if you set this up as x minus 3 equals 0, you'll notice that you're going to get x equals 3. If we plug a 3 in here, please then notice that we are going to get the remainder of 5. So when we set this up for synthetic division, okay, we have a 1, a negative 2, a negative 8. We have our divisor is 3, okay? So we're going to drop the 1 down, multiply the 3 times 1, and then it comes up for 3. Add those together for 1. Again, multiply the 3 times 1. Okay, then we will put the 3 up there, add those together. Minus 8 plus 3 gives us a minus 5. So it doesn't matter which way we solve these. Notice that we always find the remainder of minus 5. Okay, here is another example. We're going to use synthetic division to find the quotient and the remainder. So this time we're taking a negative 4x to the fifth plus x to the fourth plus 6x cubed plus 2x squared plus 50, and we're dividing it by the x minus 2. Notice that this meets our requirements. It's linear. There is no leading coefficient, and x doesn't have any exponents. Okay, we're going to set this up. Okay, so we took the negative 4, there's a 1 here, here's the 6, the 2. Notice we don't have an x term, so we had to put in a placeholder, and then we have 50. Okay, remember that the x minus 2, if you set it equal to 0, then x is going to wind up being equal to 2, and that's why we use a 2 over here. All right, we're going to drop the negative 4 down, and once we drop the negative 4 down, then we're off to the races, because we'll take 2, multiply that by negative 4 for negative 8. Then we add these two. Remember, we're always adding these, and we get minus 7. 2 times negative 7 gives us a negative 14. Okay, once we add the 6 to negative 14, we get a negative 8. 2 times negative 8 gives us a negative 16. 2 minus 16 is a negative 14. 2 times the negative 14 gives us a negative 28. 0 plus a negative 28 is negative 28. And then last, 2 times the negative 28 gives us a negative 56. We drop that. 50 minus 56 gives us a negative 6. Okay. Again, this is just emphasizing that we had to write in the 0 for the missing term. But notice that the quotient, okay, for this is, and again, that would come from these numbers here, the negative 4, the negative 7, the negative 8, the negative 14, and the negative 28. So notice that this was an exponent to the fifth, so we always write everything as the next exponent down. And we do this in decreasing order. Notice that. So we are doing this in decreasing order as we take these down, okay, from these numbers, okay. 14x minus 28, and then notice that we do have a remainder. It's a minus 6, and we could place it over our divisor of x minus 2. So that 2 is one of the forms, okay. All right, let's take a look at this one. We're going to determine whether 4 is a 0 or a root of this f of x. Okay, so we're going to use synthetic division to figure that out. So notice again, we have our leading coefficient of 1, a negative 6, an 11, and another negative 6. And those numbers wind up down along the top, okay? Remember, if we want to know whether f of 4, if it's presented to you in this format, notice that we can just put the 4 right there. that comes from the x minus 4. See how that is? X equals 4. Okay, so we're going to drop the 1 down, multiply the 4 by 1. Okay, then negative 6 plus 4 is negative 2. Again, multiply the negative 4 by the negative 2. Gives you a negative 8. We have a 3 left. 4 times the 3 gives us 12. And so we have a 6 left, okay? And because we have a remainder, then we know that 4 is not a 0 or a root or an x-intercept for this at all. Thank you very much for your participation. The end.